Hello everyone, it's Professor Capko again, and in this video we're going to learn how to easily reduce friggin fractions. Yes, oftentimes we get a fraction as an answer, and we don't like fractions that much, but we're stuck with it. But then the instructions tell you to reduce it. Oh my, what do we have to do? That's terrible. Some students will just try some guesswork, like, let me try this, let me try that. You never know if you really got it reduced as much as you can, or if it even can be reduced. Well, I'm going to take some of the stress out of it for you, and show you a technique that I think you will find helpful. Okay, I've got a list of numbers here, across here. Does anyone know what's special about those numbers? I've got 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, and ... It goes on and on forever to infinity and beyond. Well, you're right, those are prime numbers. And we want to use our prime numbers to help reduce our fractions, and that'll help us know that we've got them reduced as far as they can go. It doesn't mean that all reduced fractions are made up of prime numbers. Well, ultimately they are, but you don't have just prime numbers showing, but the prime numbers will help us get it reduced as far as it can go. So those are your prime numbers. You may want to jot them down somewhere, or you can easily look them up and find them in a book or find them online. They go on and on. There's no end to them, but I just put the first group of them. This is probably enough you'll need for most of your needs. It'll probably be enough. It's possible you need more, but then just go ahead and look them up. All right, let's say you're given a fraction like 8 over 10. I know, pretty easy. You're saying, Professor Capko, I can do that one in my head. That's okay. I want to start with an easy one so you can understand the technique and know that it works, and you can trust the technique. And then we can amp it up a little more to maybe some more complicated ones. But yeah, most people can do that in their head. If you can't do it in your head, don't worry. I'm not judging you. I'm just saying that folks will see that and will try and do it just purely through guesswork. Well, let's take the guesswork out of it. Okay, so what I want to do is I want to take each of these numbers, the numerator and the denominator, and I'm going to write them out separately. I got the 8 and I've got the 10 here. Okay, and I want to put them into what's called a factor tree. A factor tree is where I split it down into all of its prime factors. And when I do my factor trees, I want to have the prime factors to the left and whatever's left over to the right. That way, when I'm done, on the left side, I've got nothing but prime numbers. I also always recommend that you always work from the smallest prime number on up without skipping any. This way, everything will remain in order, and that'll make your life a little bit easier later on. I like to pre-plan stuff and do things a little bit organized to make my life a little bit easier down the road. Okay, I love future Professor Capko. I want to make my life easier in the future. So even if the future is only 2 minutes away. All right, so I'm going to start with the lowest prime number, and that's 2. I'm going to say, does 2 go into 8 evenly? 2 divided into 8 is 4. And in other words, 2 times 4 is 8. 2 times 4 is 8. And you could do that with a calculator as well. So this is a prime number, 2 is a prime number, so I don't mess with it anymore, because prime numbers are, as I was talking about earlier, are numbers that are divisible only by themselves and 1. And so therefore they cannot be broken down anymore. They're almost like atoms and can't be broken down any further. The 4, though, is not a prime number. It's not on our list, so we're going to try the 2 again. Does the 2 work? Again, 2 times what is 4? 2 times 2 is 4. Okay, so I've got a 2 and a 2 and a 2. Those are all prime numbers, so I know that I'm done breaking these out. So I'm going to take my 8, which I started with, and I'm going to spread it like peanut butter. 2 times 2 times 2. That only makes sense. 2 times 2 is 4 times 2 is 8. So I've taken this non-prime number and I've spread it out into prime numbers. Let's do the same for the bottom one, the denominator, the 10. Again, I start with the lowest prime number, see if it works. 2. 2 times what? Does it go into 10 evenly? 2 times 5. And you could do that with your calculator, as I was mentioning. I could start with the number 10, and I divide it by 2. Does it go in evenly? Yes, it goes in, and that's a 5. Well, 5, guess what, is a prime number as well. So this is a prime number, that's a prime number, so we're done. You cannot break it down anymore. So the bottom is 2 times 5. See, I spread the bottom out like peanut butter. Now I'm going to look at what can I eliminate. I'm going to look at what's the same on top and what's the same on the bottom. This is where doing them in order makes it a little easier because I can immediately see 2 over 2. 2 divided by 2 is 1, so that goes away. The 2 and the 5 don't go away, so I'm left with 2 times 2 over 5. Well, I cannot reduce that anymore, so 2 times 2 is 4. And on the bottom, I've got a 5. All right, so that is the answer. I've reduced 8/10 to 4/5. And that's as reduced as it's going to get. Okay, so that's step 1. That's one example of it. So that was an easy one. Let's do one that maybe is a little bit trickier. Maybe you can't do it in your head like some of you may have done. Let's say I had 75 over 120. And you got that as an answer, and it told you to reduce that fraction. Well, some of you might be able to do it in your head, but I probably couldn't. So let's see. I'm going to use the same technique. So I'm going to take my top number, and I'm going to write over here just to give myself a little bit more room. My top number is 75, and my bottom number is 120, so I write that next to it. I start out with my 75, and I'm going to start with the lowest prime number. So I can put 75 in my calculator, and my lowest prime number is 2, so I divide by 2. 37.5. That didn't go in evenly. It didn't go in, there's a little left over. There's a half left over there. So guess what? 2 doesn't work. 2 doesn't work, what do? Do we run out of the room screaming and panicking? No, we go to the next number. I put in 75 again and divide by the next larger prime number, which is 3. 3 divided by 75 equals 25. So I start with this prime number 3. 3 times 25 is 75. You can always check it. 3 times 25 is 75. Good. So I've got a 25 here. So I'm going to break the 25 down a little more because 25 is not a prime number. And I try my 3 again. Divide by 3. Does it divide by 3? 25 divided by 3? No, 8.333. So in other words, 8 1/3. 3 doesn't work anymore. So I can stop using 3. I move up to the next prime number, which is 5. 5 times what is 25? That's right, 5 times 5. Well, now all I've got is prime numbers, so I can't break it down anymore. So I got 3 times 5 times 5. So if I take my 75 and I spread it out like peanut butter, I have 3 times 5 times 5. And you can always check that, and you would see that 5 times 5 is 25 times 3 is 75. Makes sense. Draw my line. Let's do the same thing for the 120. Okay, so I take 120. I'm going to start with the smallest prime number. The smallest prime number is 2. So I got 120. I'm going to divide by 2. And yes, it goes in equally. And the answer is 60. 2 times 60 is 120. 2 is a prime number, so now I'm going to go to 60 and break that down. I didn't have it on my list here, but I'm pretty sure that's not a prime number. So I'm going to try the 2 again, see if it works. So I'm going to divide by 2. Oh yeah, it works. There's a 30. Nice. And let's try it one more time. Let's try that 2 again. Divide by 2. Yep, 15. Does 15 divide by 2 evenly? No. No, if I divide by 2, that's 7.5. So I've got 15. I need to now go up to the next prime number, 3. So 3 times 5 is 15. So now I'm down to prime numbers. So let me spread those out. So I've got 2 times 2, got this one, that one, times 2, times 3, times 5. Again, I want to try and line them up in order, so it makes it easier to knock them out. So now I'm going to see what cancels out from top to bottom. Well, there's no 2's on top, so the 2's stay. But I got a 3 here, so this 3 and this 3 cancel out, because 3 over 3 is 1. And then this 5 and that 5 cancels out, because 5 over 5 is 1. There's now 2's on the bottom and 5 on the top. I cannot break it down I cannot reduce that anymore. So I've got, on the top, I've got a 5. And that's a prime number, so I'm pretty confident that won't break down anymore. And I've got 2 times 2 is 4, times 2 is 8. 5/8. So I now have found that 75/20 is the same as 5/8. This is as reduced as it'll get. Now, for any of you who doubt that and say, Professor Capko, how can I check that? No problem. Let's start out with our original fraction, 75/20. This is really a division problem. It's 120 going into 75. So if I do an old school division, 120 going into 75, if I put that into my calculator, 120 divided by, now I do it in reverse, I got to do 75, don't I make mistake, divide by 120, right, because 120 is going into 75. That answer is 0.625. Now let's take the reduced fraction we came up with, 8 divided into 5. So I got the 8, old school division, into 5. So I go 5 divided by 8 is equal to 0.625. They both come up with the same answer, so I know that this answer is correct. So that is how you're going to reduce friggin' fractions using prime numbers. That way you know it's reduced as far as it'll go. So this shouldn't give you any problems in the future. It should make it very easy for you. All right? If you have any questions, go ahead and put them in the comments section. If you found this helpful, please go ahead and click the thumbs up and tell your friends about us. And don't forget, Professor Capko says to keep your grade alive, subscribe. Subscribe to my channel and you'll keep up with all the latest math problems coming out. Until next time, this is Professor Capko.